Welcome back to Shibi's chemistry classes. Today we are going to start acid, bases and salt, in which first will be seeing what are acids. So I have already written the definition over here. Acids are compounds that contains one or more than one hydrogen atom, and when dissolved in water they produce hydronium ion. Now we have to take some example to make this definition more clear. So what this definition is saying, that acids are compound that contain one or more hydrogen atom. Say for example, I have taken HCl and H2SO4. These two are very common acids you all are familiar with, like hydrochloric acid and sulfuric acids. So you can see the presence of hydrogen atom in this. Similarly, if we take other examples, like this is acetic acid, this is formic acid, this is nitric acid, phosphoric acid, phosphorus acid. Similarly, so many acids are there: oxalic acid, tartaric acid, citric acid. So what is the common element in all these acids? So you can see that hydrogen is common in all the acids. So that is why we here define that acids are compound that contain one or more than one hydrogen atom, and when dissolved in water they produce hydronium ion. Now we have to see this, what is hydronium ion. So one thing is clear, that yes, acids contain hydrogen as a common element in all. Now when dissolved in water they produce hydronium ion. Hydronium ion is H3O plus chloride ion. So whatever is the acidic property of acids, it is due to the formation of this hydronium ion in its aqueous solution. Aqueous solution means when it is dissolved in water, it produces this ion. This is a positively charged ion, that is called hydronium ion. Similarly, in this case, first one hydronium ion is formed with this ion, and then this ion HSO4 minus again combined with another water molecule and forms one more hydronium ion. This H2O plus this H combine and form hydronium ion, and plus sulfate ion. Sulfate is a polyatomic group with 2 minus acids valency. So this is how hydronium ion is formed. Now we will see the classification of acids. I hope definition is clear to everyone. Some examples also you have to learn. Name of some common acids. Now we will see the classification of acids. First is based on strength. Strength means how strong an acid is. So how you are going to find the strength of the acid? By the degree of dissociation of acids in its aqueous solution. When we are saying that an acid is strong, like here we are going to divide it into two parts. Strength strong acid and weak acids. Why one is called strong and why the another one is called weak? And that depends upon the degree of dissociation of acids, means how that hydronium ions are produced. And based on that, we define the strength of the acid. So strong acids and weak acids. Strong acids are those that completely ionize in aqueous solution, like hydrochloric acid. It completely ionizes in its aqueous solution, giving hydronium ion and chloride ion. Means in its aqueous solution only ions are present. When we are saying that it is a strong acid, that means it has been completely ionized with its solution containing only ions. It gives high concentration of hydronium ion. Say we have taken 100 molecules of hydrochloric acid, that means this 100 completely gets transferred or gets converted into hydronium ion. This 100 molecule of HCl getting converted into 100 molecule of hydronium ion. So that is how we say that this acid is strong. Means it is completely ionized, giving high concentration of hydronium ion, and its solution contains only ions. Whereas weak acids, say acetic acid is a weak acid. Why it is weak? Suppose we have taken 100 molecule of acetic acid, this 100 molecule will not completely gets converted into 100 molecules of hydronium ion. Say some 50 molecule has been changed into hydronium ion, rest will remain as such or as molecule in the solution. That means the solution of weak acid will contain molecule plus ions. If you will get the question that what is present in the solution of strong acid, so you have to say, you have to give answer that solution of strong acids could contain only ions, whereas solution of weak acids contain both ions and molecules, because some molecules will remain undissociated after the reaction. As such, it will remain as such in the molecular form, instead of dissociating into ions or making hydronium ion. So that is how we have classified acids on the basis of strength. That is, it is a weak acid or strong acid. Next classification, second classification, we will see on the basis of source. Source means from where these acids are obtained. Organic acid, we classified it in two ways, organic acid, and second is mineral acid. Organic acids means the acids that are mostly obtained from plants and from nature. Organic acid mostly obtained from plants, and they are mostly obtained from minerals. They are weak acids. They are generally weak and they are strong. Now weak and strong is clear to everyone. Weak means the solution contains undissociated molecules also, and here all the molecule gets converted into hydronium ion, so that is why we call it strong. So mineral acids, all the mineral acids are strong, whereas all the organic acids are weak, with one exception, that is carbonic acid. This carbonic acid is a weak mineral acid. This is an exception and you have to learn it. Carbonic acid is an organic acid, but this carbonic acid is a mineral acid, but it is weak. Carbonic acid is a weak mineral acid. Rest all the mineral acids are so strong, like HCl, HNO3, H2SO4. All these acids are mineral acids and all are strong except for carbonic acid. And weak mineral acid, we can take the example of acetic acid, formic acid. So many other acids are there, like oxalic acid, butyric acid. Means all the acids that are present in plants, they all are weak acids. One more term is there, that is oxy acid and hydra acid. You have to make yourself familiar with these terms on the basis of that we frequently hear in chemistry, and like oxy acids, hydra acids. So what are oxy acids? Oxy, from the name itself, we could make a guess that oxy acids could contain oxygen, hydrogen along with some other element, and oxygen, hydrogen and some other element. Like HNO3, you can see it contains hydrogen, oxygen and nitrogen as another element. Like H2SO4 also, you can see oxygen and hydrogen is present along with other element. And hydra acid, hydrogen along with a non-metallic element. Hydrogen with plus non-metallic element like HCl, HBr. So these are hydroacid. Hydrochloric acid is hydroacid, whereas nitric acid, sulfuric acid, they all are oxyacids. Now next classification we'll see on the basis of concentration. The third classification is on the basis of concentration. And concentration means amount of acid present in its aqueous solution. So on the basis of this concentration, again we'll classify acids in two types. One is dilute acid and second is concentrated acid. Dilute acid and concentrated acid. Dilute means it could contain more amount of water as compared to the acid. Means in dilute more quantity of water is present, whereas in concentrated acid very less quantity of water is present. Okay, dilute means more water. And in concentrated less water is present. And whenever you have to dilute an acid, you could put acid in water. And whenever we are required to dilute an acid, so there is a particular process for dilution that we have to put acid, drop by drop of acid is to be put in water instead of putting the reverse. Instead of putting water in acid, you have to put drop by drop of acid in water. Because if you put water in acid, it is a highly exothermic process and very large amount of heat is liberated. So that is why we put acid in water for dilution process. So dilute means more amount of water is present and concentrated less amount of water is present. Now we will see basicity. Basicity of acid. Next classification is on the basis of their basicity. Now basicity is the number of hydronium ion produced by the ionization of one molecule of that acid in its aqueous solution. What I said, basicity is the number of hydronium ions produced by the ionization of one molecule of acid in its aqueous solution. Let's take some example like HCl, aqueous solution. You can see here that one molecule of hydrochloric acid is giving one molecule of hydronium ion. So we can say that its basicity is 1. Its basicity is 1. Means the amount of hydronium ion produced by the ionization of one molecule of acid in its aqueous solution. So here you can see that hydrochloric acid, one molecule is giving one molecule of hydronium ion. That means its basicity is 1. So it is an example of monobasic acid. So hydrochloric acid is an example of monobasic acid. more example. This is acetic acid, ionization. So here also you can see that acetic acid, one molecule, after ionization giving one molecule of hydronium ion. That means the formation of hydronium ion is not dependent upon the number of hydrogen atom in the acid. You can see that here acetic acid contains 4 hydrogen atom, but it is producing only one molecule of hydronium ion, means its basicity is 1. So basicity is not dependent upon the number of hydrogen atom. It depends upon the number of ionizable hydrogen atom. Ionizable means that can go ionization. So you could have a little bit knowledge of structures also for this. How could you know that how many hydrogens are ionizable in this sample? So you could have a little idea of structure also. Carbon, its valency is 4. This carbon is with double bond, it is attached to this O. And this is a methyl group, OOH. So this H that is attached to this oxygen is ionizable, means in aqueous solution this hydrogen will get removed from here. So it is actually this hydrogen atom that is producing hydronium ion. Understood? Not this one. This 3 hydrogen atom is attached with this carbon, and this group, this entire group is called methyl group. This you will study in organic chemistry. This entire group is called methyl group. This hydrogen is not ionizable. It can't detach itself from this carbon. But here the hydrogen that is attached to oxygen is ionizable, and it could easily detach or remove itself when water molecule enters and it combines with this water molecule and form hydronium ion. So that is why acetic acid, its basicity is 1, because it is forming only one molecule of hydronium ion. Now next we will see diabasic acid. So basicity is actually the number of hydronium ions produced. So we will see second is diabasic. Diabasic, di means 2, that means it could be forming 2 hydronium ions. So we'll take an example of sulfuric acid. On ionization, it will give, first it is going to produce one molecule with this one hydrogen atom. Both the hydrogens are ionizable in this case. So first one water molecule combined with one of the hydrogen atom of this sulfuric acid, and HSO4 ion is formed. This HSO4 ion again combined with water molecule, and one more hydronium ion is produced with the formation of sulfate ion. So here you can see that one molecule of sulfuric acid is producing 2 molecules of hydronium ion. Or we could write this equation like this: H2SO4 plus H2O giving 2 molecule of hydronium ion plus sulfate ions. So combined equation is like this. So that means one molecule of sulfuric acid is producing 2 molecule of hydronium ions. So that means its basicity is 2, or it is a diabasic acid. Now we'll take an example of tribasic acid, that is phosphoric acid. Tribasic acid is phosphoric acid. H3PO4. Try to do it by yourself. All the 3 hydrogens are ionizable. So first one hydronium ion is produced with H2PO4. One hydronium ion is produced. Then this H2PO4 again combines with water molecule and forms another hydronium ion, then HPO4 2 minus. Then this HPO4 2 minus combines with third water molecule and forms hydronium ion plus phosphate ion. So this is how you could see that one molecule of phosphoric acid is producing 3 molecules of hydronium ion. So it is a tribasic acid with basicity 3. So I hope this concept is clear. What the number of hydronium ion that is getting formed over here is not at all dependent upon the number of hydrogen atom. It is independent of this number of hydrogen atom, and it depends upon the number of ionizable hydrogen atoms in the molecules. So I hope this classification is clear. Now we will see preparation of acids. First method of preparation is by synthesis. First is by synthesis. We are going to see the preparation of acid. That means we will be preparing sulfuric acid, sulfurous acid, hydrochloric acid, hydrobromic acid, HNO3. So these are some of the acids. Just learn these names. You are going to see these acids again and again during the entire chapter. So you have to learn this, that H2SO4 is sulfuric, H2SO3 is sulfurous, then HNO3 is nitric acid, hydrochloric acid, hydrobromic acid. So these are the common acids. So first method of preparation is by synthesis, in which we are going to prepare only binary acids. Binary means acid that contains 2 elements. So we'll take acids with 2 elements like hydrochloric acid, hydrobromic acid. Rest acids, they are having more than 2 elements. So in this method, by synthesis, you are going to prepare only acid that are containing only 2 elements. So here you can see that hydrogen and chlorine are present. So just do one thing, combine both of them. H2Cl2. These are diatomic molecule, means they exist in this form. So 2 atoms join together. So Cl2, H2, like that. They exist like that. They are diatomic molecule. So to form hydrochloric acid, we want hydrogen and we want chlorine. So combine both of them, you will get hydrochloric acid and balance. Similarly here, hydrogen and bromine you want, combine it and then balance it. So this is the most simple method in which we will be preparing binary acid by synthesis method. Next is by the action of water on non-metallic oxide. By the action of water on non-metallic oxides. Since oxides are there, so we are going to prepare oxyacids by this method. Now in this method, we will not be preparing binary acids. These are hydra acids. HCl, HBr, these are hydra acids. By this method, with the action of water on non-metallic oxide, we will be preparing oxyacid. Oxyacids, what are they? Like sulfuric acid, nitric acid, sulfurous acid, phosphoric acid. So these are oxyacid, that contain hydrogen, oxygen along with other non-metallic element. So what we are going to do, action of water, that means definitely one side, in the reactant side, water, so definitely we have to take. Okay. Now suppose we want to prepare sulfuric acid. I'm just giving you the trick to learn the equation. You need not to just memorize it. You can just make a trick and then learn it. See, sulfuric acid. I said that we have to prepare oxyacid. So oxyacid's example, by now that these are the examples of oxy acid. Take this on the product side, and you can just see what elements are there: sulfur, oxygen, hydrogen. So one side, in the reactant side, take water, and what else you could take? You could take non-metallic oxides, means non-metals along with oxygen. So take a non-metal here, sulfate group is there, so definitely we want sulfur in this reactant side also. So take sulfur and make its oxide. So its oxide, suppose sulfur trioxide we have taken, sulfur trioxide reacted with water, form H2SO4. This is sulfuric acid. Similarly, if you want to make sulfurous acid, H2SO3, we know that we have to take water as one of the reactant. Take sulfur dioxide, it is also an oxide of non-metal. Sulfur is a non-metal, and when it combined with oxygen, it forms sulfur dioxide. So it is an oxide of non-metal. So you got sulfurous acid. Now suppose you want to make carbonic acid, H2CO3. Take water and what else? Non-metal and its oxide. So carbon dioxide plus water, you will get carbonic acid. Now suppose phosphoric acid, H3PO4, H2O, and what else? This you have to learn. Phosphorus pentaoxide. So you will get H3PO4. Balance it. You have to balance how many P? 2. So make it 2. 2P, 3 2 is 6, 3 2 is 6, 8, 5, 6, 7, 8. Now the equation is balanced. So this is how you have to prepare oxy acids by the action of water on non-metallic oxides. Now the third method is by the oxidation of non-metals. Now what is oxidation? Oxidation of non-metals. Says sulfur is a non-metal. HNO3, nitric acid, is an oxidizing agent. It furnishes oxygen. Oxidation is the addition of oxygen. And so what the oxygen that is needed in oxidation process is going to be furnished by this nitric acid, because this nitric acid act as an oxidizing agent. So we have taken a non-metal and an oxidizing agent, and then after the reaction, what you are going to get? Sulfuric acid plus water plus NO2. Similarly, if you could take phosphorus and nitric acid, so you will get phosphoric acid. So these are some of the method for the preparation of acids. Now in the next lecture we are going to see the properties of acids. Till then, have a nice day.